Hi, this is Mrs. Kidman, and welcome to part 2 of absolute value functions. So remember, our central question for this section of chapter 1 is to figure out how the values of a, h, and k affect the graph of an absolute value function. Now this video, we are going to focus specifically on how k affects the function and what it does. So let's look at a couple of examples to see what happens. So first, let's look at the graph of this function here. G of x equals the absolute value of x plus 3. Now I want to compare that function there to the graph of the parent function, which is this f of x equals the absolute value of x. The way that we're going to do that is we are actually going to go to Desmos and we're going to type in both of these functions and see what happens. So let's head over to Desmos and see what is going to happen. So as I open it up, the first thing I want to do is graph my parent function. So that's the f of x equals the absolute value of x. Now notice over here, that is our function in red. It looks like this. Pretty straightforward. Now let's graph that new function, that g of x. So g of x, we're going to see what happens if I take the absolute value of x and I add 3 to it. Now notice that this new function here, this g of x, is our blue function. So look at what happened. Originally, our function had a vertex here at 0, 0, and now it's shifted up to a vertex at 0, 3. Interesting, right? So it looks like it just took our exact function and it moved it upwards. What do you think is going to happen here with the function h of x? Well, let's see what happens. Now this h of x function, it is going to be a different color. So h of x is green here. And when we do x minus 1, look at what happens there. So again, this green function that we're looking at, that function is part B. Red is our parent function, or the absolute value of x. And blue is that part A, or the absolute value of x plus 3. Notice, as we add these numbers to the outside, so as we add this plus 3, what happens to our graph? It shifts it up 3. As we add this minus 1 here, look at what it does for our graph here. We shift down 1. And notice how that vertex has changed. So coming back to this idea of what goes on with those values, we saw based on those graphs that the function shifts, right? It will shift up when this is positive. So notice how this is a plus 3. And what did we observe? It shifted up. And what about this one, where it's negative? Yep, that's right. This one shifts or shifted down. And you'll notice that this occurs with every single one. So as we talk about how the variable k affects our function there, our original function there, we can see that if that k is positive, it's going to shift our graph up. If that k is negative, it's going to shift it down, just like we saw in that graph on Desmos. So that's exactly what's going to happen with our k's there. So that's kind of the note that we want to make. If k is positive, so if k is positive, then we are looking at a shift up. If k is negative, we are looking at a shift down for that negative k. And that's going to occur every single time. So as we look at these different graphs, or as we're given these functions, we can see and we can guess. So say, for example, we're given this function here. We had g of x equals the absolute value of x plus 4. I can tell you, because it has a plus 4 here on the outside of that absolute value signs, that's like my k. What that's going to tell me is that compared to our parent function, which I have here in blue, this new one is going to shift up 4. If we had a different function, like h of x equals the absolute value of x minus 5, the same thing would happen. Here's our parent function, or just f of x equals the absolute value of x. the -5 will have the same function but shifted down. And that's all that k does, is it affects how it goes up and down.